Alrighty, guys, we are gonna look at the next section in our notes. This is page 6. So we talked about a lot of exponent rules over the last couple of days. Some of them should have been familiar. Maybe some of them were new. Last thing we looked at were those rational exponents. So when my exponent is a fraction, how do I handle that? And the idea that these rational exponents represent roots of some kind. So today we're going to talk about actually evaluating this exponent. So up to this point, we have seen primarily some sort of variable with an exponent as we've practiced all of our exponent rules. Here and there have been a couple of actual numbers sprinkled in that we could simplify. But for the most part, we've seen variables with exponents. So today I want to talk about evaluating when I have a number to a power. Okay, so this should be familiar, but I want to talk about it because I see mistakes on things like A fairly commonly. Okay, because what we do is we like go a little too fast, and then you tell me 5 to the third power is 15. Okay, what's the mistake you're making if you tell me 5 to the third power is 15? You're doing 5 times 3, but what should we be doing? Good, 5 times 5 times 5. Now, I don't see it a ton for something like 5 to the third power, but I do see it a lot for 2 cubed. Okay, I do see it a lot for things like 4 squared. So be careful on those things. That's why we're taking some time to talk about this today. Okay, so remember, exponents represent repeated multiplication. So make sure when we're evaluating exponents, it's multiplying that number by itself however many times. Not 5 times 3, but 5 times 5 times 5. Okay, and what is 5 cubed? 125. Good. Okay. Also be careful with negative numbers. We talked about this the other day, but a negative number and a negative exponent are different. So this would be -3 times -3, which would give me 9, positive 9. If we had 3 to the -2nd power, that means take the reciprocal, 1 over 3 squared. So just be careful with that. Okay. We deal with squares a lot. In geometry, you see squares. In algebra 1, you see squares. Every once in a while, you maybe see a cube. But for the most part, before algebra 2, you don't deal with a whole lot of exponents bigger than 3, especially not with negative numbers. A lot of times we're squaring a negative number for something we're doing in geometry or algebra 1. But I want to remind you that just because I have a negative number to an exponent does not automatically mean that number is positive. So if I have -1 to the 5th power, that is -1 times -1 times -1 times -1 times -1. Okay, so there's a positive, and then there's another positive, and 1 times 1 would give me 1, but then I have another, since it's odd, I have another negative. Okay, so be careful with powers of negative numbers. A lot of times we drop the sign out of habit, but remember, if I have an odd power, I'm going to have an odd number of those things. Okay, so I'll have a negative answer still. What about 2 to the 0? Just 1. Anything to the 0 power is 1. Again, there's a little asterisk next to 0 to the 0, but that depends on the context. 4 to the 1/2 we saw last time. Remember that rational exponent means we are looking at the square root of 4 to the 1st power, and the square root of 4 is 2. And then for f, I've got those all sort of built in together. Instead of a rational exponent, I'm giving you the cube root of 8 squared. What I want you to remember when you are evaluating roots and powers together is that this, the cube root of 8 squared, is the same as the cube root of 8, then squared. I want you to remember this because for some of us, this is an easier thing to evaluate than this. So if I'm following order of operations for this, I am taking the cube root of 64. Okay. If I'm following order of operations here, I'm taking the cube root of 8, which is 2, and then squaring that. Now we get 4 both ways, but for some of us, this is an easier problem to think about than this, okay? For some of you, maybe this is easier than taking the cube root and then squaring, but I want you to remember you can think about it both ways. I want to talk about evaluating negative exponents on an actual number. So we talked about when I have something like x to the negative second, that means 1 over x squared. And we talked about it just a little bit, how that means reciprocal, but I want to talk about when I'm actually evaluating numbers to a negative power. And I'm going to start in a place that might seem a little counterintuitive when I evaluate numbers to a positive power. So 4 or 2 to the 4th power. 2 to the 4th would be 16, okay? 2 cubed would be 2 squared, 2 to the 1st, 2 to the 0. Okay, so we're going to pause here for just a second because I want to point out a couple of things, okay? So I want you to notice that I dropped the power by 1 each time. We see that? We had 2 to the 4th, and then 2 cubed, and then 2 squared. What happened to our answers each time? Like, what's the relationship between 16 and 8? Yeah, cut it in half. I divided it by 2, right? I divided out a 2 each time. I divided out a 2 each time as that exponent went down, okay? So 2 divided by 2 is what led us to 1. Now, if negative exponents are something that you like conceptually are having kind of a hard time with, okay, here's what I want you to do. We can continue this same power when we talk about negative exponents as well, okay? So 2 to the 1st would be our previous answer divided by 2, right? I went from 0 to negative 1. So as I drop that power, I can take my previous answer and divide by 2. For 2 to the negative second, I dropped the power by 1 again, so I can take my previous answer and divide by 2. So this would be 1 over 1/2 times 1 over 2, which would be 1/4. If I drop the exponent again, we can take 2 to the negative second and divide by 2, which would be 1/4 times 1/2. And then I want you to notice what I see here is that reciprocal. It is 1 over 2 to the 1st. 1/4 is 1 over 2 squared. 1/8 is 1 over 2 cubed. Do we see that? Okay. So if I wanted 2 to the 8th, I don't want to have to go from 1/8 until I've divided by 2 that many times.
1 over 2 to the 8th, which is 1 over 256.
Good. Notice that none of my final answers here were negative. So a negative exponent does not mean that number is now negative. Okay? Be careful with that. In general, if I've got something to a negative exponent, we're looking at the reciprocal. As long as a is not 0. Why do I have to put that disclaimer there? What would be the problem if my base for the exponent were 0? I'd be divided by 0, and that is undefined. Okay, so as long as the base for our exponent is not 0. Questions for me so far? All righty, turn the page. So we're going to talk about evaluating exponents, because one of the things that we've done already and that we'll continue to use is to be able to create a table. So if I want to create a table for a quadratic function or a linear function, right, we pick some values for x and we plug them in. Eventually, this will help us when we get to graphing. I want to be able to do that for an exponential function as well. And in order to do that for an exponential function, I need to know how to evaluate exponents. Okay? So I want to be able to plug in negative numbers and 0. right? And fractions potentially, right? A rational exponent. So 1/2 might be a decent value to plug in for x for some of our problems. I'm not going to use 1/2 as an exponent here. Why? Why would I not want to do 3 to the 1/2 power? Mhm. Yeah, I would end up with the square root of 3. And if we're talking about eventually using a table to graph, is that going to be a nice number to graph? No. So I'm going to stick with integers here. And then we've done stuff like this already, right? Plug in those values for x, see what we get. Right? It's like an extended evaluate problem. So 3 to the negative second means I take the reciprocal, 1 over 3 squared, which would be 1/9. 3 to the negative first means I take the reciprocal. I have 1 over 3 to the first, which is just 1/3. 3 to the 0, what's anything to the 0 power? 1. And then 3 to the first is just 3. And then we've got 3 squared, which is 9. And then we've got 3 cubed, which is 27. Our exponential functions can be more complicated. This is a pretty simple one. We can have a sort of a coefficient here. We can change stuff in the exponent. We can add or subtract stuff at the end. So if I look at something that's maybe just slightly more complicated, 4 times 2 to the negative second, can I pick the same x values to plug in for this x, for this function? Sure. Would I want to do like a 1/2 or a 1/3 on this one? No, the 2 still isn't going to have a nice square root, right? If I had maybe 4 to the x, then plug in a 1/2. Sure, that's fine. If you had 8 to the x, plug in a 1/3. That's fine. So this would be, if I use those same x values, 4 times 2 to the negative second. So take your reciprocal. And what would I get here? You get 1, right? 4 times a fourth. 4 times 2 to the negative first. Don't forget your reciprocal. And we get 2. Finish your table for me. What's the y-intercept for f of x? This is a throwback. 1. What's the y-intercept for g of x? 4. And then some more problems that should look familiar, stuff we've done already. Evaluating, we've got some function notation here. We've got some compositions here. This is all stuff we've done before. We're just looking at it where we've got to evaluate some exponents along the way, okay? So for g of 2, that means I'm going to g of x and I'm plugging in 2 for x. So this would be 2 to the negative second. So 1 over 2 squared. You get 1/4. For b, we have a composition here. Remember, work from the inside out. So h of 1, we start there. We plug in 1 for x. This would be -2 times 1 to the first. That gives us -2. And then I take this as my input for f. f of -2 means I've got 3 to the -2nd. Take the reciprocal, 1 over 3 squared is 1/9. I would like you to try C, D, and E. Try the next 3. For C, remember work from the inside out, so it's f of 2. That would be 3 squared, which is 9. And then that becomes our input for G. So G of 9 is 9 to the -2nd. So 1 over 9 squared. You get 1 over 81. Questions on that one? Okay. For D, this is another composition. So f of -1 should be 3 to the -1st, which is 1 over 3. And then we use 1/3 as our input for G. So this would be 1/3 to the -2nd. We're taking a reciprocal here. That means I have 3 squared. If you want to take the long way on this one, we could say that we've got 1 to the -2nd over 3 to the -2nd. This moves to the bottom. Oops. This moves to the top. So you would have 3 squared over 1 squared. The other thing that you can do is the reciprocal of what you have inside your parentheses, which would be 3 squared. So we get 9 there. Okay, so for some of our exponent rules, as we've talked about before, if I've got multiple things going on, right, it's not just a negative exponent, it's a negative exponent of division or of something that looks like a fraction. There are multiple ways that I could arrive at the same thing. And then E, I'm evaluating, and multiplying. So G of 1/3, well, we just did G of 1/3, and we know that that's 9. G of 1/3 I know is 9. H of -1/2 means I've got -2 times -1/2 to the -1/2 power. In parentheses here, this would be 1. 1 to the -1/2 means I'm going to take the reciprocal, and I get 1 over 1 to the 1/2. And then this would be 1 over the square root of 1. And the square root of 1 is just 1. So I've got 9 times 1, which is 9. Questions on E, particularly how I got the 1? All right. Take your time with these, write down your work. Okay? It is very easy to skip ahead and try to do it all in your head, and then we miss little things. So be careful with these. Last one, F. F of -1. So this would be 3 to the negative first, which is 1/3. And then we're going to add h of 2. So h of 2 would be negative 2 times 2 to the second power. So that's negative 4 squared, which is 16. So we have 1/3 plus 16. 16 1/3. Questions for me on our evaluating for today? Not too bad? Homework tonight are the problems on the next page, okay? L3 practice on page 8. You might notice the next thing in your packet is review. Tomorrow, we're going to spend about the first 15 minutes or so working on review, and then quiz with the second half of class, just so you have a heads up there.